So let me write it. So in a reverse way. So that is dou r if you want. Dou r equal to dou x into dou x by dou r. That's easy, no? Plus dou y into dou y by dou r. So what is this one? This gives you cos theta. Dou x by dou r is x equal to r cos theta, right? So that will give me cos theta dou x plus sin theta dou y. So this is your dou r. So dou theta is the same way. If you do, instead of r you put theta. Okay, so you get dou x comes out. So dou x by dou theta is minus r sin theta dou x. R cos theta, the r sin theta, if you differentiate with respect to theta, that will give me r cos theta dou theta dou y, right? Dou y. So these two you just invert it. If you invert this, you will get dou x dou y, right? This is how you do. So what is the inverse? Now can you give me the inverse? Dou x dou y is actually the inverse matrix of cos theta sin theta of dou. Yeah, that is the inverse, right? So the cos theta dou x, sin theta dou x. That is the first equation. Similarly here, minus r sin theta, r cos theta. This inverse acting on dou r, dou theta. This is how you do. So if you do whatever you calculate here, what is this inverse? What is the inverse? 1 by r, right? 1 by r,
Yes, sir.
1
Yes,
by
sir.
r. So that's the determinant, right? So that is 1 by r. And now what you do here? So this is simply put r cos theta here,
And cos theta here, or minus
again,
sign multiplication.
sin theta, r sin theta. This you have a dou r, dou theta. So if you invert it, so what you get is basically 1 by r, r goes, so you have a cos theta dou r minus 1 by r sin theta dou theta. So this is one. And what is the other one? So you simply r sin theta. R goes sin theta dou r,
Dodo R.
and here plus 1 by r cos theta dou theta. So this one, these two you substitute in your dou square x by dou square plus here f dou square f by dou y square. You come and substitute these things. This is for dou x twice if you apply, and you write this one. Okay, so if you use this one, this becomes your actual Laplace equation. In dou r, you will get dou square f by dou r square plus 1 by r dou f by dou r plus 1 by r square dou square f by dou theta square. Okay, so this is the usual procedure which you do in calculus. So here you didn't miss this one. So what happens here? How you miss that one if you directly use your gradient of f, right? So gradient of f I got. You may think that okay, this is what it is. So dou x is equal to this. Dou y is this. But what you got is different, no? Isn't it?
Yes, sir.
So uh, you can't equate, I think, right? So that means you only gradient of f is this one. This is earlier these are like ij. Earlier here these are ij component, ith component, I cap, j cap components. Here you have a different components, ur component and u. What is it? What did we use? EU, right? ER and E theta components. They are different there. So that's why you can't first equal. Okay, you can't equate. That is one. So that is the reason, and also dot product. So dot is, that's why it's missing. Okay, that is not true. So what do you do now? So for that reason, we need del dot, right? So you don't equate like that. So you instead you try to calculate del dot some vector valued function. So the vector valued function, if you say where f is, let me write what is f. F is f1. Now you see it's a function of UVW, right? So it's your coordinates. So those things, if you put it f1 of EU cap plus f2 of UVW, that is also EV cap plus f3 of EW cap. Okay, so such a thing you want dot product. Dot product you want. So that is your once you convert this into UVW, so this is how this vector field, and you have a gradient dot product. So that's your divergence. Okay, so this is your divergence in the curvilinear coordinates. What happened? Somebody is out or someone? Okay, advance report. Okay, so now how am I going to do this one? Del dot u. So what I do is I choose f. Let me choose my f as rather okay. So not this one. So what I choose is earlier. You know what you know is gradient of f, right? Gradient of f is known. Let okay. So let this f be equal to u. Simply u or v or w. Then what happens to this? Uh, so what happens to gradient of u? Gradient of this u. U equal to is what? 1 by hu, right? 1 by hu into what do you have? Dou f by dou u, right? So the dou f by dou u is anyway 1. So into EU cap. And all the other things are 0. Plus 0, EV cap, EW cap. Those coefficients are 0 because dou f by dou UV, dou f by dou W will be 0. Okay. So similarly, so implies,
Yes, sir.
yeah. Hello. So if you actually see this modulus, what I get is HU. Okay, because since EU cap modulus equal to 1, those are unit vectors. So what is that I get here? So EU cap equal to HU into HU. What is that you get? So if I want to write in terms of let me write. So EU cap equal to HU into gradient of U, right? HU into gradient of U. So HU is actually 1 over gradient of, so gradient of U divided by its modulus, gradient of U. That's what you will get. So similarly, EV cap is also something like gradient of V divided by gradient of V. If I take F as V alone, okay, and EW cap is also, I can write like gradient of W divided by its modulus, gradient of W is what you have. Okay. Now what is that I need? Why do I need this? All these things? Because del dot F. So in Cartesian coordinates, del dot F is actually what do you do here? Del dot F is equal to what do you do? Del dot. So this is your F1 EU cap plus F2 EV cap plus F3 UW cap. Sorry, EU, right? So that's EV cap plus F3 EW cap. So this will give me f1 is anyways it's a scalar function. So it comes out. What you get is del dot u cap plus. Then if it is a scalar function, another term is gradient of f1 into u cap. This is what is the first term. So similarly, you have other terms. That is f2 into divergence of this unit vector ev cap plus gradient of f2 into ev cap plus f3 divergence of ew cap plus gradient of f3 into ew cap. So what we know here? So I know this one, right? So I know all these things. These three I can replace here, right? So this here I can replace them. So what I need to understand is only these things I need. The divergence only I require with the unit vectors. Those things you calculate. So if you actually see dot product with EU cap. Let us start with this. So what is EU cap? It's a unit vector, right? It's a unit vector that I'm going to write it like
Vector u by modulus u.
uh, uh, no, I'm not going to write like that. So what I do is EU, EV, EW are perpendicular, right? Those are unit vector perpendicular with the orthogonal curvilinear coordinates. So U cap actually equal to EV cap. Of course, with orientation we are writing cross product with EW cap. Okay.
Yes, sir. Yes.
EV EW we know that is HV gradient of V cross product with HW gradient of W. So what you have is HV HW into gradient of V cross gradient of W. Okay. So you put it here. So I'm going to write it as dot product with uh, HU, this one, just like HU, HV, HW into this vector del V cross del W. Okay, so this is equal to, now you have seen, no? So how you have done here, the first term, same way you write it. So this will give me uh, F1. So no, not F1. So what do you have? So this one you will put it outside, HV, HW. These are scalar quantities into divergence of del V cross del W. Okay. Is this 0? Just calculate and see me. Tell me what it is. So this one, and then what else? What is the other one? Plus uh, gradient of this scalar function HV HW. Uh, that's that dot product with del V cross del W. Okay. This is what we have. So the first term HV HW into del dot. You calculate this del dot del V cross del W. What is this one? Why is this 0? Divergence of curl is always 0, no? For any two vectors, this is 0, right? This is simply divergence of curl of two vectors, okay? Not curl, right? So it's a cross product. Can you just check that this is 0? For Cartesian coordinates, that is good enough. You calculate Cartesian coordinates, okay? So just take it as an exercise, and this you calculate this, okay? So this will give me 0, and what you get is gradient of HVHW. Okay, now dot product with what is gradient of V, gradient of W? We already calculated 1 by HV EV bar, EV cap, cross product with 1 by HW EW cap. So this will finally will give me 1 by HVHW comes out. These two will come out, and you end up getting gradient of HVHW dot product with what is this one? EV cross EW is EU, right? So simply EU.
Yes, sir.
That is EU cap. So this will give me 1 by HVHW. These are numbers or functions. And what is this one? This we know, right? By yesterday, we have done the gradient of this. That will give me 1 by HU times, what do you do? 1 by HU times dou U, right? Dou U of HU, HV, HW. This function, dou F by dou U. Instead of F, I have HU, HV, HW. So this into EU cap. Dot product only, that is EU, EV dot EU, EW dot D. Those terms will be 0. Okay. So this is the only term will be there. So remaining thing will be 0. So this is equal to 1 by HU, HV, HW. What else is there? That's all, right? So you have dou U of HU, HV, HW. That is what is this divergence of this unit vector, EU cap. So now you can write similarly. Similarly, del dot EV cap, this will be as it is, HU, HV, HW. Only thing is dou V of HU, HW. Del dot EW cap equal to 1 by HU, HV, HW. Dou W of HU, HV. Okay, so now you just go and substitute into your del dot F, all this. Now you have everything, right? Del dot F equal to, now I'm putting F1, first term is F1 into the del dot EU cap. So that is giving me 1 over HU, HV, HW, dou U of HV, HW, plus, what is the other term? What is the other term that we have?
F2 plus.
Gradient of F1, right? Gradient of F1 dot product with EU cap is gradient of F1
Yes, sir.
again 1 by HU dou F1 by dou U into EU cap. That only will contribute. Other terms will be 0. Okay. So this is your first term, first coefficient. Second coefficient I'm writing similarly. So F2 1 by HU, HV, HW dou V of this will be HU, HW plus 1 by HV dou F2 by dou V. Similarly, the other one. So F3 1 by HU, HV, HW. These things you can calculate now. If you give the transformation, all these HU, HV, HW can calculate it. F1, F2, F3 are given. So these derivatives you can calculate. So that is what is the dot product. So here dou W of HU, HV plus 1 by HW dou F3 by dou W. So this is what is your divergence of a vector field here. Any questions up to here?
Sir, here F is a force vector or anything else, sir?
Yeah.
Excuse me,
F,
sir. Am I audible?
yeah. Tell me. What you're asking something?
Here F is a force vector or anything else, sir?
It can be any vector, right? Similarly, vector field, no, you do divergence with a vector field. So that's basically in terms of EU, EV, EZ. So EW, this form. So three
Okay, sir.
components it has with those unit vectors of U, EU, EV, EW. This is true for any F.
Yes, sir.
But in but
Sir,
in the
can you little bit explain?
but in the curvilinear coordinates, UVW. So those are all functions of UVW. Where did we write this one? That is where Fi equal to Fi of UVW. Okay, so I is any vector field. So so this divergence is this. Okay.
Okay, sir. So could you elaborate little bit how we will use divergence of vector in fluid dynamics, sir? Where you will we will use,
We'll
sir?
use, yeah, we can do
Uh,
for example, this polar coordinates if you are using, if you want to use del dot the UVW vector. What is this one? This is actually your first equation, right? This is your mass equation you will get. This is your mass equation. Conservation of mass will give you
o-
function of flow. So if you actually do this one, no, so this will give you
okay, sir.
what you need. So this is equal to 0 will give you something in your some equation in this UVW coordinate. So for example, r theta coordinates. If you want, you may be interested in polar coordinates or cylindrical coordinates. Okay, so we'll see that one.
Okay, sir.
So
Okay,
right
sir.
now we use this one. So this is what it is. Now if we use polar coordinates. Now if I have used in polar coordinates, example, uh, polar, polar coordinates. So what are the polar coordinates? R theta only, no? So you have only two components. So what is the del square F if you want? Del dot del F. So you can write now what it is. So what is del F? Del dot del F is what?
Del F,
1 by HR.
del F
HR
by
is
del
what?
R, del F
Yeah,
by del R.
dot R ER cap plus 1 by R dot theta E theta cap, right? So only two components, right?
Okay,
So this is
okay,
what we have. So this is now this one. I put it as this one, right? So that I need to put that down. This is understood. So this is plus means that. Okay. That's a vector in r theta. These curvilinear coordinates. So now you apply your formula, whatever you have got. So instead of F1, what do you have? This is dou F by dou R. This is dou F by dou theta. Dou F by dou R is your F1, right? So dou F by dou R equal to dou F by dou R into 1 by HU H theta. HR H theta. HR is equal to 1, H theta equal to R. And then dou U is R. Dou R of what is that H theta? U theta only you have. U, okay? So if you want to use EW, you consider this polar coordinates are your W. Okay, so you just use your W. W as Z. Okay, Z if you take HW equal to 1. So what do you get here? So dou R of simply this is 1 only, right? This is U theta, V equal to theta. So U theta is R and into 1. So that is simply gives you 1. Okay, plus 1 by HU is 1, dou F by dou R, isn't it? That one, second term also you will get. What is the second term? Plus, now 1 by R, 1 by R, dou F by dou theta is your F2. 1 by R, I'll write plus here, okay? So plus 1 by R dou F by dou theta as your F2, 1 by HU H theta. So again, I'm having only two components here, okay? HW ignore otherwise. So HU H theta 1 by R times here. What do you have here? Do V means do theta of do theta means HU HV, right? HU only. That you have HU. That is only one. One if you are using cylindrical coordinate system, for example. Okay. So you just use this polar or cylindrical. Okay, not polar. Similar only. Okay. Cylindrical. Cylindrical. If you put, it's a kind of polar. It's Z. So if you use, I can use R into 1. So here 1 into 1. Okay. What is 1? HR is 1. HZ is 1. What is HZ? What is HZ? Dx you have, no? Dx square plus dy square plus dz square. So that's the one. HZ. What is HZ? Yesterday you have done, right?
Yes.
Just look back. How do you get this your HZ? HZ is basically dou R by dou X, or rather dou X by dou Z, dou Y by dou Z, and dou Z by dou Z. So what you are getting 0, 0, 1 now. This modulus is actually your Z. Okay? But dou X by dou R, dou Y by dou R, dou Z by dou R, that is actually gives you 1 again. Right? That is giving you HR. This is HZ. This is going to be 1. So you get like this, and you have other terms also, right? Dou theta of, now what is this HU HV I wrote? So I wrote what did I write? Only first term I wrote. This term I wrote. Okay. Now plus 1 by HV, that is 1 by R times, what do you have here? Dou F2 by dou V, that is dou theta of, what is my function? This one. So 1 by R times dou F by dou theta. So now this is 0, right? This is a constant. So what do you have here? Dou F by dou R into this is 1, right? So simply 1 by R times this plus dou F by dou R plus this whole thing is 0 plus 1 by R square dou square F by dou theta square. Somewhere I think I missed that square, no? So where is it coming? Where is that dou? Yeah, I think I missed this one here. Dou R, no? Dou R of this one. So that is going to be dou square F by dou R square. This one, right? So 1 by HU is 1 by 1, HU is 1, dou U, that is dou R of that function, whatever is here, F1 is dou F by dou R. Can you see this? The third term is there, that you can write it, that becomes 0. Okay, so that actually it won't become 0, so you can write it. So what is the third term? If you use cylindrical coordinate system, what is your third term? Then I have to add here, no, gradient of F. So what is the gradient of F? One more term. So plus EW, that EW is Z, no? Z cap. What is that you get? 1 by HW. 1 by HZ is 1. 1 by HZ is 1 into dou F by dou Z. Now you can write your third term. So what is your third term? So your third term is dou F by dou Z. Dou F by dou Z outside into 1 by HZ, HR, H theta. That is 1 by R. Dou, what do you have? Dou Z of dw, no? W is Z. Dou Z of HV, HW. So that dou Z of H means H theta and HZ. HZ is 1, H theta is R. That is anyway 0, becoming 0. What is the next term? What is the last term? 1 by HW, that is 1 by 1 into dou Z of, what is your function? Dou F by dou Z. So if you add this last one, this is 0, and this will give me dou square F by dou Z square. In polar coordinate, this cylindrical coordinate system, if you remove this, that what you get is only polar coordinate. Okay, followed. Any doubts up to here?
No, sir.
So this is an example where you can see. So for example, if you are only using the two-dimensional flows, some circular flows, for example, then you can use only r theta. If you are using in a three-dimensional flow, axisymmetric, some kind of circular flows, where if you are using this system, cylindrical coordinate system, you have this one. Okay. So gradient of f is this one.
Excuse me, sir.
Yeah.
Actually, I am confused, sir, like where we use HZ, HR every time, sir. That's why, sir, I cannot get
You have
properly,
to
sir.
calculate your hz. So what is your hr? Hr is though x is r cos theta, right? X is r cos theta.
Yes, sir,
What
yes,
y equal to
yes,
r
sir.
sin theta.
Why is
Z,
ask?
z
Yes,
equal
sir.
to, right? Z
Did
equal to z only, right?
yes,
Z is z only. So what is hr? Hr is
yes, sir. Yes,
modulus
sir.
of dou x by dou r, that is cos theta, cos square theta plus dou
Do
y by dou
do
r square, right? That is sin, sin square theta plus dou z by dou r, that is 0 square, right? Square means under root, right?
yes,
That's what you do, right?
yes, sir.
Modulus, but modulus is that.
Yes, sir.
So modulus is that square root, right? So the modulus is that square root. So or you put it like, let me write again, modulus of the vector. So what is the vector? Dou x by dou r, that is cos theta, dou y by dou r,
Cos theta,
sin theta,
comma, sin
dou z
theta,
by dou r. So
sin theta,
this
or
is actually square root of
zero.
cos square theta plus sin square theta plus 0. So this is simply one. Similarly, h theta. What is h theta? Modulus of this vector. What is the vector that you get? With respect to theta,
Okay,
you calculate.
okay,
Now,
I understand. I understand the formula, sir.
okay, fine. So then
Yes,
just write
sir. Yes, sir.
sin theta
And
r
sir,
cos theta. This is 0. This will come as r. Similarly, hz. Hz is,
uh,
this is 0, 0.
yes, sir. Yes.
Okay, that
Zero,
is
zero, one,
0,
one.
0. Yeah, this you have to calculate
Uh,
once you are given your transformation. Once you have a transformation, you have to calculate these two first. Okay, and then you have a gradient of f. So gradient of f. Now you can.
okay, sir. I think
Now you know,
yes,
right?
yes, sir. I think I have to revise. Yes, sir. I have to revise all those things again. Yes,
Okay,
sir. Yes,
okay,
sir.
fine. So
Yes,
now
sir.
we know the
Thank.
divergence also. So we can do now similar way for curl also. Curl of this some vector field f.
Okay, sir.
This is the curl part in
Yes, sir.
in in curvilinear coordinate system. So if you write like this, f we know
Sir,
f1 to e.
sir, before the derivation, can you little bit elaborate like divergence, physical meaning, and curl, sir, so we can visualize
That will
like
come. So
that
basically, divergence is what is the divergence you get?
dot like
Divergence of a vector, for example. Divergence means basically a flux. This is the flow, right? This is the flow. The
yes,
amount of
sir.
fluid that goes out of a surface, okay,
Okay,
out
sir.
of this one. That is actually
Okay.
gives you that. You know, you studied no that vector calculus. That you must have seen the physical significance, right? Gradient
Yes,
of
sir. Yes.
gradient of f is basically gives you. This is f is a surface, right? F equal to 0 equal to constant is a surface. Gradient of is f is always perpendicular to the surface at that point.
Yes, sir. Yes, sir.
So divergence
Yes,
will
sir.
give you the amount of fluid that goes out of. Okay, that's kind of flux.
Okay, sir.
Divergence, whatever comes in mass. No, if you just consider this area element or the volume element, how much fluid is coming in, coming going out. Whatever comes in goes out, then divergence is zero. Effective, effective quantity coming inside. That is what it is.
Okay,
That
sir.
is different. Del cross U means it represents something like you see you have a flow like this. Del cross U means it's perpendicular to this U. Okay, so that may be this direction or maybe perpendicular direction if it is three dimensions. You don't know exactly, right? So,
Yes,
for
sir.
example, your flow is like this. That means the curl. No, curl means it's a calculation. So in this case, you may have your that is always perpendicular to this. So these are your streamlines. It's perpendicular to streamline. So it's basically that axis, which will go into that direction. So it's like a screw. Screw you try to make a screw. You turn it. No, either it go towards that direction. No, so that's how it works.
Okay, sir.
You direction. If you see perpendicular is perpendicular to this point. The axis to this. That here you don't know because this is your u direction, uniform flow, for example. So what is across you maybe perpendicular only. Okay, like that these three. So I think I will try to revise again when you do this. Okay,
Okay, sir. Okay, sir. Thank you, sir.
so, so whenever we do those equations derivation time, we will do. Okay, so that is what is so the curl also do the same thing. So now I explained what is curl. You simply mathematically you write del cross f1 into EU cap. This is what we read plus del cross f2 into EV cap. Okay, plus del cross f3 into EW cap. So we need at least any one of them. So one of them you try to write. So how do I get this one? Del cross this one. Del cross. So let me only calculate this del cross f1 EU cap. This is equal to we know. So this is del cross f1. What is EU cap? EU cap you have written, right? So that is given as H1, that is HU gradient of U, isn't it? Just now we have done, no? HU into gradient of U is U, right?
Yes, sir. Yes, sir.
Okay. You're using that one. So that I replaced. So now you have only this F1 HU and this vector. So this, if you write it, this will become uh, F1H comes out as a HU comes out as a scalar function. Del cross del U. This anyway 0. Curl of a gradient is always 0. This is always 0. Plus, what else you have? Gradient of
F1HU.
F1H. F1H a dot product with dot or curl with gradient of. So you need to calculate this one. So this if you calculate, so what I do is I'll put it like this. Gradient of H, this you know, right? So this you can write now. So what is the gradient of F1HU? Now we have HU dou F1HU by dou U EU cap plus 1 by HV dou F1HU of dou V plus 1 by HW. Of course, into is there, right? So into EV cap. So 1 by HW dou F1HU, this function with dou W into EW cap. This you are cross multiplying with what is del U? Del U is, what is del U? EU cap divided by HU, right? Again, I'm reusing again. Okay, isn't it? HU gradient of EU.
Yes, sir.
Yeah.
Sir, each component of any vector is also depend upon UVW. That's why if we differentiate,
Yes.
okay. That's why
So
sir, I'm
now,
confusing. I'm
now
confusing
this
with if F1HU is scalar, then why it's come like this.
F1
Oh,
HU is a scalar, right? So you have, right? So you have something like let's say something happened.
yes, sir, now it's fine.
See what happened here is you generally write gradient F cross F some vector field F. Okay, gradient of not gradient, some other vector field, let us say. If you put a vector field means u bar. This formula is what? F into del cross u. Okay. This is one plus del gradient of
Yes,
f.
sir. Yes, sir. Chain rule, sir.
This is what I use here. Okay.
Yes.
So now EU cross EU is anyway zero, right? They are parallel. That is zero. So you will be ending with only these two terms. So what is the terms that because they you have to use your usual orientation. So if you write that one, so equal to 1 by HV HU, HV and HU, and dou F1 HU of dou V. EV cross EU is what? Minus sign, right? You have a minus sign of
EW.
EW. Yeah.
Yes, sir.
So what is the other one you will get? The other one will be plus sign 1 by HW or HU
HU
and
and
dou F1
EW on
of
K cross
W.
K cross
Now
I.
EW into EU is EV cap.
Yes, sir.
Okay, so this is your first one. The similar way you can write and finally add it up. Okay, so if you do that, so you will get your curl immediately. Right. This similarly you write and then just add them up. You end up getting. Can you write that one? Similarly,
Yes, sir.
cross F2 EV cap. One I will write, you write the other one. So this is equal to, yeah, now which one is minus, which one is, that you need to be a little careful. Yeah. So I'm writing directly. The second term is, what is the second term you get?
Sir, 1
Uh,
uh, what's it?
by
1 by HW HU.
1 by HU HW. Yeah.
1 by del of F2 HV.
You're finally getting, it's like a V, no? It's going to be V here, cross product with the delta V. Okay. So that's going to be with the delta V, gradient of V. Gradient of V at the last, this term will be the gradient of it. So it will be EV. EV goes. UV become W here. Okay. So first one is EW cap
Yes, sir.
with positive sign. So you have only dou into F2 HV by dou U, right?
Yes, sir. Yes, sir.
Dou U. And this is going to be minus or plus, the last term. So here
Minus, sir.
EW cross EV, that is also EW cross, that is going to be minus. So 1 over that HW into HV, correct?
Yes, sir.
And dou F2 HV of dou W here, right? Dou W. And this EW cross EV, W cross EV means a negative sign, and that is going to be EU cap.
UU. Yes, sir.
So you write the same way the other component. Okay. So when you write finally, okay, I'll write one more. So it won't take much time. So 3 EW cap. EW cap is what? So you have the same things. This will be same. Here EW cap by HW. So U and W will give me negative sign, right? First one.
Yes, yes, sir. U and W gill minus EV.
EU cross EU cross EW will give me minus
EV.
EV component. So EV cap, first of all, that you are right. And then what you have? So this is HW and HU. Okay, 1 over HW and HU. So into F3 into
F3 SW, sir.
W by dou U. That's
Do
one
you?
component.
Yes.
WW only the second component will contribute. EVW means VW means EU
Yes, sir.
component 1 over HVHW into dou F3 HW of dou V, right?
Yes, sir.
That's all. So these are the three things. If you add it up, you end up getting
Curl.
one. Okay, curl. So, but this is a very complicated thing. So if you add it up and see that, if you actually see that both are same, so del cross F, if you do it, it is going to be 1 by HU, HV, HW. You, like your thing you want, you can remember. So this is going to be, if you do this one, what is that? HU, HV, HW. And what is your first one? EU. Your vector is okay. So you just see that both are same. Okay, that you do the exercise I'm writing. So what you do is you write one all HU, HV, HV 1 over that into here U into EU cap, HV into EV cap, and then HW into EW cap. These are the three components in the first term. And then dodo U, dodo V, dodo Z, dodo W. Okay. And here HU F1, HV F2, HW F3. So if you actually try to do this determinant and what you add all these three components, del cross F will be same. So you can put it in this form. You can remember this one. Okay. In general. Okay. Can you do that as an exercise? Hello.
Yes, sir.
So show that they are there. It is actually same. Verify. Okay. So verify after this. I'll put as verify.
Yes, sir. I
You
will
can put it
try,
in
sir.
this form. Okay. So you do this one. This you
Okay,
do
sir.
this, and then from this you can directly now you put this. What is del cross F? Del cross F in polar coordinate. Polar or vector? Polar also you can do, no?
Yes, sir. And
Polar.
in cylindrical also, sir.
Yeah, you can do just polar coordinates. It will be easy, so that it will be zero. So what you get is del cross F equal to in polar coordinates 1 over HU H theta. HW simply you can't have. Okay.
Yes, sir.
So simply one. You take it as one. Okay. So your polar coordinates are actually dodo this thing, no? So what you get, this will be zero, right? So this will be zero. Dodo, there is no, this thing means only this one, this component. Only two components will be there. Let's write cylindrical. Okay. Cylindrical means it's easy for you. So that 1 by R into 1 into 1. Okay. And then this you have modulus. I mean this determinant. HU 1 U cap 1 into E R cap. What else? R into E theta cap 1 into E Z cap. That is simply right. That is K only. What else you have? So dodo R, dodo theta, dodo Z. That is your second row. Instead of UVW, I am putting R theta Z. Then you have H1, HU, F1. So HU is 1, right? So 1,
Yes, sir.
then
1 F1, R F2, F3.
F1, RF2,
F3.
F2.
Yes,
That
sir.
is actually will give you curl
Yes.
in
Yes.
cylindrical coordinate system. What happens in the polar actually?
It's a 2
So
cross 2
polar
matrix,
is
sir.
Z
2
equal
cross.
to 0. So I think you need to take only this part. Huh?
Yes,
So
sir.
exactly how you do that one, I'm not sure. Can
I
you do
I
it
guess
again?
only I guess only we get 2 cross 2 matrix, sir.
This will be there. This will be
Yes.
there. I don't know. Maybe this formula it's for 3 by 3, full three coordinates. But if you do only for two components, only these two, ignore this. you may end up getting something. So that you have to see exactly how we do.
Okay, sir.
So mostly we use only polar coordinate. Okay. So this is cylindrical coordinates. Similarly, spherical coordinates system. All the whatever you have done. Okay. Exercise you take it. Uh, write gradient of f, that is dot f, spherical coordinate system. You write and see it will be there in every textbook. Okay. All the textbook they might have listed. So if you do once and see that they are same, that's fine. Okay.
Okay, sir.
You have this formula to remember, right? So the del cross, you have this formula to remember. This you keep in mind. And general, those are the general coordinates. And del dot thing, how do you remember? So you don't have, right? So you don't have you have only this. You don't have choice. The divergence, I think you need to keep it and apply. You don't have to remember. Okay. Nothing I ask. Okay. Don't worry about exams. Exams, I'm not going to ask you to remember and write it. So don't worry about that. So these are the reference things. These general coordinates. When you need, just look at them and write it. If you don't remember. Okay. Otherwise, do it once so that see that whatever written in the textbook, they are actually same. Okay.
Okay, sir.
So
Okay,
what
sir.
are the things that you have is polar coordinates. We generally use polar coordinates. Second one is cylindrical. Third one is spherical. There is a third one, fourth one. This is we normally don't use, but it might be useful in fluid mechanics. Those are toroidal, torus kind of some other some toroidal coordinate
Sir,
system.
I don't know this toroidal coordinates, sir.
Doesn't matter. You give some transformation. That's all. This
Okay, sir.
so you don't worry about that one. Okay. So those are related by x equal to c plus r sine p. To draw and see, you try to write it in the Google, you might see that how they look like. Okay. So y equal to c plus r sine p sine. I think it's like no spherical that what do you call that spiral way you go, right? So that way I think
Yes, sir. Yes, sir.
z equal to r cos p.
In
Something similar
magnetic
to
field,
something
electric field is.
something similar to spherical, but you're adding that c cos theta, c sin theta. Maybe that's the only difference, right? Otherwise, it looks like your spherical only, right? Yeah, this is just spherical only, but you're adding that c cos theta, c sin theta. Okay. So this you take it as what are the coefficients now? So these are r system r theta and phi. So those are the three. Exactly what are those coefficients? Where they belong? That we don't know, right? So it's not given. So just find out. Okay. So let me give you exactly where it is. No idea. Let's see. You don't worry about its geometry. Geometrically, on where exactly this belongs to. R is anyway greater than 0. So this theta and phi also same way. So what is theta here?
0 to 2 pi, sir.
So R theta is 0 to 2 pi. Yeah, I think the same thing. Okay. Phi should be
And
0 to pi.
to 0 to pi, yes, sir. Same as spherical coordinate?
Same as. Yeah, something similar, but you don't know. Just find out how they look like in the spherical coordinate system. You know, there are spheres, there are
Yes, sir.
cones, and there are some kind of planes. There are three things. So here, what happens? You have to see.
Okay,
Okay,
sir. Okay, sir.
so that is called this toroidal. No idea. Okay, so but mathematically, you know how to write all these things. If required, only we do. So what we require is mostly we don't really use here. That is, you need to know if required. If you are working in fluid dynamics, you can use it. Otherwise, we try to do some exercise only using polar coordinates maximum on cylinder. Two-dimensional polar coordinates. Okay. Cylindrical maximum three-dimensional flow, special flows if you are working. Okay. But I think this curvilinear coordinate system is done. So if you ask me any questions, I'll leave it here.
Okay, sir. Please share all the notes.
Yeah,
We
all
will
the
revise.
yes, yes,
Yes,
yes.
sir.
I will
We
do
will
that.
revise. If we have
Yes.
any doubt, then I will ask, sir.
Okay, fine.
Okay.
Huh? Yeah. See you tomorrow. We'll
Okay.
derive some equations tomorrow.
Okay, sir.
Okay, conservation of mass and momentum will try to derive tomorrow. Okay.
Okay, sir.
See you. See you.
Thank you, sir.
Yeah, thank you. Bye.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you. Bye.